So we have vertex form here. To use vertex form, you need a coordinate point x and y, and you need a vertex h and k. Now we talked about the vertex being the bottom or the top of the parabola, and if we know that coordinate point, and we know one other coordinate point there, an x-intercept, a y-intercept, some random point, we can write the equation. But I've done the first problem for you, so you can kind of see what I'm going to eventually do. But if you look at this equation, I'm going to highlight those letters that I've already highlighted in the top. So here we have x, and then we have y, and then we have h, and then we have k. What's the only letter not highlighted? A. I want you to underline the letter A right now. The letter A is the only letter we don't know. Letter A controls the reflections, it controls the stretches and the shrinks of this parabola. So we have to find the letter A using algebra and then plug the numbers in. So what I've done here in this first problem is I've shown you these 3 steps. We just need to finish it out. So let me walk you through what I've done so you have a nice pretty version of this written on there. Mine's in color, yours is obviously printed black and white, but you can kind of follow along. So the first thing I did is I looked at this parabola and I found the vertex. We see that the vertex is at the coordinate point 2, -2. So that's my h and that's my k. That's why I put those numbers here, h and k. Do we see that? Yeah. Great. Then the only other piece of information they give me for this parabola is a coordinate point somewhere on the parabola. That's fine. I can use that. That's going to be my x and that's going to be my y because it's a coordinate point x, y. So I put x and y. I then took the pattern from the top of my paper and I filled in those numbers where those letters go. So the first thing says y. What number did I label as y? 6. So that's why I put the 6 first. And then equal to a. Do we know what a is yet? No, so we put the letter a. What was x? 4. What was h? 2. What was k? Do we see how I filled in all those numbers where they go just in that formula? What's the only letter that I have left? A. I want you to circle or underline the letter A right there. That's the only letter we have left to solve. If you have one equation, you can solve for one letter. So the steps here, all I did was literally solve for A. Can anybody tell me what I did from this colorful line to the first line written in black? What's the only thing I did there? From here to here. Subtract 4 minus 2. What is 4 minus 2? 2. Great. PEMDAS tells me I have to deal with the exponents first. So what is 2 squared? 4. So from the second step to the third, all I did was 2 squared. That's 4. I moved the 4 to the front of the A because we like putting whole numbers in front of letters when they're multiplied. What did I do on the next step? I showed you my work. I did plus 2 because I want to solve for A. I want to get the A by itself. So I added 2 to both sides. If you would please cross out the numbers -2 and 2 so you know that those cancel out. Then what did I do on that last step after I get 8 equal to 4A? Divided by 4 so I could get the A by itself. Cross out the 4's. We have 2. Fabulous. We have done steps 1 and steps 2 from the top of this page. Step 3 says to substitute what 3 letters? A, H, and K. Great. Back into the regular vertex form, which means we're going to leave x's and y's in our vertex form. My final answer here would be y equal to A, which we just found was 2, open parentheses, x minus h, which we labeled earlier was 2, close parentheses squared, plus k, which we said was -2. Again, all I have to plug in is the number I found for A, the number I found for h from the graph, and the number I have for k from the graph. So we're writing by hand these formulas for these quadratics, given different pieces of information. If you're given the vertex, you use vertex form. Plug in what you know, solve for what you don't. Let's try another one here. All right. We're going to write an equation of a line that passes through a coordinate point 4, -7, and the vertex 1, -6, and then in classic form, there's a typo. Can y'all close that parentheses for me? LOL. Oh, dear. Okay, so we have a bunch of information. The number 4 and -7. Is that just a random point or is that the vertex? This one right here is the vertex? Oh, it's just one random point. It's going to say it's the vertex if it's the vertex. So we're going to label those X and Y. So that's my coordinate point. 4, comma, -7. So X is equal to 4 and Y is equal to -7. That's on the coordinate point. Now my vertex, what two letters make up my vertex? 1 and -6. The letters are H and K. So for my H I have 1 and for my K I have -6. I have 4 numbers I can plug in. I have a number for X, Y, H, and K. So we're going to plug them into this vertex form equation. I have it kind of helping you out with some training wheels here. I have blanks for you. What goes in this first blank right here? What letter? Y, which is the number? -7. So we're going to put a -7 there. And then we have A, which we don't know yet, so we leave as a A. What's the next letter in the formula? X. So what number am I putting there? 4. What's the next letter in the formula? H. So what number am I putting there? 1. And then the last but not least, -6. Amazing. I've plugged all these things in where they go from the vertex form formula. What letter do I need to solve for? A. So we're going to follow the same steps, which means the first thing I do is something with the parentheses. What do I do in that parentheses first? Actually subtract them. What is 4 minus 1? 3. Okay. So then we have this equation. -7 equal to A times 3 squared minus 6. What is 3 squared? Don't say 6. 9. Remember, squaring is multiplying that number by itself that many times. So 3 squared is like 3 times 3. Okay, so we have -7 equal to 9A. I like putting the number in front of the letter instead of behind it once we have just a single number, minus 6. What's the next step in solving for A? We're going to get A by itself. Do we deal with the 9 or with the 6 first? The -6. How do I get that -6 to go away? Opposite, which is +6. Cross out the 6's. -7 plus 6, consult my brain or consult my calculator, is -1. What's the very last step here? Divide by. Very good, because we want the 9's to cancel out so that A is all the way by itself. And yes, you're going to get a fraction every once in a while. That's okay. -1 divided by 9 does not reduce, so A is going to be equal to -1 divided by 9. If it does reduce or does actually, divide into something, you can divide it. But 1 divided by 9 is just 1/9. Okay, we've got all the things now. What 3 letters in the last step do I substitute back in?
X, H, K.
Not X.
A, H, K.
A, H, K, yeah. A, H, and K. If you want, it makes a funny sound if you say those letters together. It makes the sound ach. So if you want to think to yourself, I have to do math, those are the letters you're going to put back in. So we leave the Y as a Y equal to whatever the A value is, open parentheses, X minus H, which we said was 1, squared, and then K, which we said was -6. Again, all we have to plug in at the end is A, H, and K. Now, vertex form is not the only form of a parabola that we're going to be writing today. On the inside, there's another one called intercept form, where it gives you your x-intercepts. So the things I'm going to be given this time is some random point x and y, and then 2 x-intercepts labeled P and Q. Why P and Q? It's because we just decided those would be the letters for the intercepts. But those are where the graph crosses the x-axis. If you notice, this equation for intercept form uses y, uses x twice, and uses both P and Q. Again, what letter did I not highlight right now? A. We still need to find A. So underline it again. The steps are going to be very, very similar. You plug in what you know. You solve for what you don't. If you look at step 3 here, previously we plugged in the numbers A, H, and K. But what does number 3 say you're going to plug in this time? A and P and Q. Very good. So this is a different formula, so we're using different letters. Okay, let's look through this first example that I did for you, and so we can get to the final answer. You're given this picture. On this picture, am I given the vertex? I actually am on this one. You won't always be given the vertex. And since we're not using vertex form, we're not going to label those X and Y, or sorry, H and K. We're just going to label them X and Y because we want an X and Y coordinate that I can plug into intercept form. But we also want the numbers for the intercepts. Where does the graph cross the axis on the left side? And where does it cross on the right side? 4. So do you see how I got the numbers for that first part of this problem? I said that it has a coordinate point at 1, 5. So X is 1 and Y is 5. And it has intercepts at -2 and 4. So that's P and Q. We see how, yes? Okay. We fill in what we know. I didn't give you the blanks here. So what I'm doing is I'm filling in the formula from the top of the page. Look at the top of the page. What letter comes very first?
5.
Letter. Y, which is the number 5 in this problem. And then it says equal A. Do we know A yet? No, so we have to find A. If you want to write this down or circle or highlight the letter A, that's what we're going to end up finding. The formula next says open a set of parentheses and then put what letter here? Letter. Look at the top of your page. What letter is right after the parentheses? X. And then it says minus what? P. Why did I end up putting +2 right here? Can y'all tell?
Because there was a negative to it switch.
Yes, it's a -2, so it switches signs. So if you start filling out this formula, there was a minus sign there. If I have a minus sign on my 2, I just made that a whole plus. You see how I made the green part the plus instead of the minus? You can do that. And then I close the parentheses and I open another one. What's the first letter in the second parentheses? X. And then I'm going to subtract what? Q. So you see you're just plugging the things in where they go in the formula.
So you do opposite value for the first one?
Technically both of them. So if this was -2, I see +2. If this is +4, I see -4.
So opposite value for both?
Yes. Why do they flip? Because we're plugging in a positive number to a negative equation. It's a really great question. So this formula already has a minus sign in it. So if I plug a positive number in, it doesn't change the minus sign. But if I change and put a negative number here, it would be like minus a minus. What's minus a minus? Positive. Minus a minus is plus. That's why it changes. Okay, so from the step when I plugged everything in on your paper, what did I do from here to here? From this one to this one?
You just add and subtract.
I just add and subtract. I simplify the parentheses. If you want to write that down for yourself, that's what we did on that step. I simplify the parentheses. From this step to this step, where'd the -9 come from?
The 3.
3 times -3, isn't that -9? So I'm multiplying these two things together. I'm putting it in front. What's the very last step?
Divided.
By
Negative.
-9. Okay, if we want to, we can cross those out so you can tell that's why we did that. And then we have the fraction 5 over -9, which doesn't reduce at all, so that's my value for A. What 3 letters am I plugging back into intercept form? P, Q, and A. So let's do that. That means we want there to be a Y equals. Then we plug in the number we got for A. Then there's an X minus the number P, which was -2, which means that changes to positive, right? And then X minus the number 4. Where I plugged in A, P, and Q, where P and Q make the signs opposite. It's a really great thing to notice. P and Q will always be opposite signs. It's very, very similar to the vertex form. The letters are just different. So we have a different place to plug them in. Can we do an example together? Mm-hmm. Great. This time you're not given a graph, you're just given the information. It says you have an x-intercept of -5 and 8. What 2 letters is that? P and Q. I'm going to highlight mine green because that's what I've been using for P and Q. So here's P and here's Q. And it says it passes through the coordinate point 1, 84. So what is the X value? 1. And what is the Y value? 84. Don't panic that that number's big. It will be okay. Okay, let's plug in what we know. The formula at the very top of my paper says Y. What did we write down was equal to Y?
84.
So we're going to do 84 equal to A. Do we know what A is yet? No, so I'm going to leave that as the letter. And then I have X. What is X? 1. And then I'm going to subtract P. What is P? Negative 5. So I'm going to make that a plus sign with a 5 because it was negative. Close that parenthesis, open a new parenthesis. What number goes next? Ooh, X, which is 1. And then I'm going to subtract 8. Woo, that's a lot of plugging stuff in. But we just literally plugging in the numbers that are labeled X, Y, P, Q. X just gets to be plugged in twice because there are 2 X's in the equation. All right, what do I do next? Simplify. We're going to look at the 2 parentheses and we're going to change those numbers. So 84, I'm not going to change yet. A, I'm not going to change. But what is 1 plus 5? 6. And what is 1 minus 8? Negative 7. So there we go. I've simplified both parentheses. That's just little adding and subtracting. I keep simplifying. I'm going to multiply those 2 parentheses together. What is 6 times negative 7? Negative 42. So I have negative 84 equal to negative 42A. I got it, Ruby. All right, one last step. What is that last step in solving for A? Positive 42? Negative 42. So I divide by negative 42. And 84 divided by negative 42 is negative 2. Ooh, I told you not to panic. You might get fractions. You might get big numbers. You might get small numbers. That's okay. This one was a nice, pretty number, negative 2. Oh, man, now we need to actually write the equation. What 3 letters this time am I plugging back in? A, P, Q. A, P, and Q. That means literally just think not X's and Y's. X's and Y's go back in as X's and Y's. Everything else we plug in. This would be Y equal to negative 2, open parentheses, X minus negative 5, which means that makes positive 5, multiplied by X minus 8. Cool beans. How do we feel? All right. What I want you to do now is, if you don't have your Chromebook out, I need you to go open a Desmos tab. So get your Chromebook open, and I want you to open a new tab. While we're writing equations by hand, which I'm going to ask for you to do, there is also a way to write equations on Desmos. Now, you would have done this last year, but I know it's been a whole summer, and you're like, tried to trash that information. Please don't do that. Please keep our information in your brain. But what last year did you do when you were given a table in Desmos? Put it in. I want you guys to do that because now we have to make choices on whether the information we're given is a linear equation, is a quadratic equation, or is neither. So I'm going to give you a few minutes. I want you to type in that whole table on number 5 to Desmos. I'll give you a second. After you type it all into Desmos, there's this Zoom Fit button. I really like clicking the Zoom Fit button because your calculators have a very similar feature. When you click Zoom Fit or when you just scroll out, it does this with your data. So my question for you, the data you see on your paper, does it make a linear shape? Like I kind of drew onto your paper. That's not just like random dirt. That's intentional. Does it make like a line? Does it make like a parabola, either happy or sad, or does it make some other sort of shape?
A line.
This makes a line?
Yeah, that's like straight.
Straight would be like this. What is this doing right here?
It's curving.
It's curving.
That was quadratic.
So this is quadratic. So if we look at the data, that's why the zoom fit button is really helpful, because if I just zoom out normally, I don't know how it's fitting my data. Ew, that's weird looking. If you press zoom fit, it's going to show you the data really, really well. So if that's not showing up for you, you might be on the testing version of Desmos. That's for Algebra 1. You can just use regular Desmos for Algebra 2, unless I say otherwise. I'm glad that you were so trained to pull up the testing version. That makes me happy. But this one, since it looks like a parabola, we would say this is quadratic. It has what's called not constant rates of change. So we're going to write that down. Not a constant rate of change. It technically has a constant second rate of change, but you don't need to know that necessarily. It's called a second difference. If you're interested in that, I will explain it further outside of notes time. But if we just look at it and it doesn't have a constant rate of change, doesn't have a common difference, then it's either quadratic or neither. Now let's do the second one. So we're going to take this second information and type it into a table and press the zoom fit feature. I'll give you some time to type. Okay, so when we type the second one in and we press zoom fit, oh, I missed the zoom fit button. What does it look like?
Straight line.
A straight line. So what kind of equation is that? Linear, because it looks like a line, linear equation. Now, linear equations have a constant rate of change. That's why they're called linear, because they go in a line. They're changing the same. The first differences between all those y values is all the same. It's going up or down by the same number. If we do number 7, and I'm going to show you number 7. I don't want you to spend the time typing it. But if I turn on number 7 and I press zoom fit, does that make a curve?
Yeah.
Like it goes back up?
No. Yes.
It does?
Yes.
Look at this.
Yes.
Does this one go up from that one?
No.
No. Does it all go in a straight line? No.
Curve.
This is just one random side curve, not a U. It's kind of like a half of a U. This one is actually neither. It wouldn't have a constant difference or a constant second difference. It would have no sort of scenario where it's the same in its differences. This is actually a type of equation we studied in Algebra 1. Does anyone remember what it's called? This is just like for a quick buck sort of thing. It starts with an E.
Here.
No, that's some science stuff. Equals MC squared. I'll give you the second letter. EX. Oh, what'd you say?
Exponent.
Close.
Exponential.
Exponential. This is an exponential equation. Instead of going up and down by a certain number in its first or second differences, this one is multiplied by a certain number. You don't really need to know that for today. We'll go back over exponentials later in this class. But that was a bonus question for you. This one, though, for today, we're just going to say neither. Okay, because it just makes this shape. And just so you remember what you were looking for on your notes, we're going to go ahead and draw these shapes in. So we had a line for linear, we had a curve for the exponential, and we had a parabola for quadratic. Those are the shapes you're looking for to determine whether this data is linear, quadratic, or neither. And the reason we care about determining whether the data is one of those three things is because we want to be able to get information from a science experiment, from a study of some sort, and predict the future. That's what we're going to do in number 8. Number 8 says the table shows a university's budget over a 10-year period where x is equal to 0 represents the first year in the 10-year period. Use a graphing calculator or Desmos, we're going to use Desmos, to create a scatter plot. Which better represents the data, a line or a parabola? Okay, let's answer that question. Type along with me. So I press zoom fit on this information. My only options here are line or parabola. Does this look like a straight line?
No.
Does it sort of look like a parabola? I mean, this one's a little out of place, but doesn't it go down and then come back up?
But it's like, it looks like nothing.
It's not a perfect parabola, but what is better? Because this question says which better represents it. Our only options are line or parabola. Is a line better or is a parabola better?
A parabola.
Agreed. So for this one on letter A, because it makes a U-ish shape. It's not quite perfect. We would say that this is going to be a parabola, which, yes, means that this function is going to be a quadratic function or quadratic regression. So we're going to use a regression calculator to find the model, which is a fancy way of saying equation, that best fits the data. By the way, if you want to change this word model to the word equation, it's going to best show me the data. I have written the formula down that you need. This is, I know it's kind of small, so it feels like, Miss Quigley, you know, you could have put that bigger. I know. This is the formula you type in after a parabola. I know last year when we did linear equations, we typed in a different formula into Desmos. Does anyone remember that formula? Ooh, okay, y1 squiggly line, mx1 plus b. What kind of equation was that for?
Linear.
A slope or for linear. Great. If you're asked on your homework, which you will be, to do a linear equation, that's the formula you use. But when you're asked on your homework, which you will be, to do a quadratic regression, you're going to use this one. So I want everybody right now to type that in. And it has funny typing because if you notice on the x squared, it's both got a 1 that's underneath it and then a square. So I want you to figure out how to type that for a second. Like x1 shift 6 square. It'll work, I promise you. Okay, when I do this part, my Desmos spits out to me 3 numbers. I need those 3 numbers, and we're going to round them to the nearest 2 decimals. How many decimals? 2. So if I were to write down these numbers that I got and put them in the correct formula, it would be y equal to 1.49 x squared, because that's a, plus 0.51 x plus 39.98. Okay, so these numbers, I just take them and I put, sorry, I just realized you're like, I can't see it because you have the graph over it. You're right. I put them in the formula in the order that they come, A, B, C, because that's the order I wrote down the equation, A, B, C. That's the formula for this parabola. You didn't get those numbers?
Wait, could you redo it?
Yeah, we got this.
I got 3 and 1, 1, 1, 1. Yeah, that's what I was.
Oh, no. Okay, now that we fixed that, remember, your tables have to say x1, y1, and they actually have to be in your computer. Ooh. We're going to use the model, which, remember, model meant equation, to predict the budget of the university after 12 years. If they tell me 12 years, did they tell me an x value or a y value?
Why did you go open the page?
How do I change it?
Okay, if they tell me 12 years, did they give me an x value or a y value? Wait, years is y? Look at the table.
There you go.
It's an x value. So we're going to go back to our table and we're going to plug literally this equation into Desmos. When you plug that equation into Desmos, x equal 12, it gives you a vertical line that now crosses your prediction. Where does it cross your prediction? Well, 12 comma what?
260.
Okay, great. I'm going to take that coordinate point, and the 12 is what they gave me. The other number is what I want. Bless you. This would be my answer. However, this context of this question says that these numbers are in millions of dollars. So the final answer here is actually $260,982,000. Whew. Because that number is measured in millions. So we just made it $1 million. Okay, you guys have part D. I want you to use the model, which is the equation, to predict the budget of the university after 15 years. If it wants me to predict in 15 years, I just change that x value from 12 to 15. My coordinate point now tells me 383.391 for y, which is $383,391,000. Oh my gosh, you can't even think in that much money.
If I had too much money, I'd buy this school.
I think we would let you buy the school too at that point if you had that much money.